Hello everyone. The title of this video is Using Interval Notation. Alright, now each example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 2.7, Linear Inequalities and Absolute Value Inequalities. And I'm working under the heading Using Interval Notation. Now each example I'm going to do is either going to be an example from the reading or one of the try it problems from the reading or one of the exercises at the end of this section that's related to this particular objective. I would request that whenever I bring up a new example, whenever I start a new example, pause the video and try to work it out yourself first before watching me do it and then comparing, because I really feel that you should be practicing these on your own, as well as watching me and not just watching me do it. Okay? Great. So all the examples I have for you are written out on paper here, and we're asked to use interval notation to indicate the set of numbers, right? So interval notation is a way to indicate a set of numbers, right, as we're asked to do. So in these first several examples, I have just a description of numbers in words. You can describe the same set of numbers in many different ways. You can describe a set of numbers in words, like we have here. So all real numbers greater than or equal to -2. Right, so we can describe it in words. We can describe that same set of numbers with a graph. I'll just do this here. A picture. Right, draw a picture of the numbers that are being described. So when I graph, we're just talking about the real numbers only. So I'm going to draw a real number line. All right, remember how the real number line works. There's 0 somewhere, and then you have positive numbers to the right, +1, +2, and all the numbers in between, of course, and then it goes that way forever. And then negative numbers to the left of 0, -1, -2, -3, and so on, and all the numbers in between, right? Not just the integers. And if one number is left to the left of another number, the number on the left is considered smaller, and the number on the right is considered greater. Right? So -3 would be considered less than -2. -1 would be considered greater than -3. Right? All right, so in a picture, we're asked to just identify, all the real numbers greater than or equal, right, or equal to -2. So both of these, right, or is very inclusive, right? So I'm going to indicate all the numbers greater than -2 first. Those would be all the numbers to the right of -2 on the number line. So I'll draw a little arrow, in highlighting and pointing in the direction of all the numbers greater, to the right of -2 on the number line. And then equal to -2 as well. So for equal, I'm going to put a closed dot, a filled in closed point above -2 to indicate that -2 does belong to this set of numbers that I'm describing here. If it weren't included, I'd put an open point. We'll see that later in the video as well, in later examples. And I'd put an empty point above a number if it wasn't included. Then you have something called set builder notation. This is another way to describe or indicate the same set of numbers. So let's say I called these numbers something. Say I called them x. X represents any number, real number, greater than or equal to -2. So this set of numbers, I put like a little, start with the set braces. And I say this set of numbers that's described here is the set of all values of x such that x is greater than or equal to -2. Right, writing a little inequality, right? This is the is greater than or equal to symbol. And then close the braces, close the set. So it's all real numbers x such that, x is a number greater than or equal to -2. So you have a variable here and then conditions on that variable after like a little bar or a colon. Alright, this is called set builder notation, and it's describing the same set of numbers that this graph describes and that these words describe. Right? And then finally, we get to this interval notation. To describe the same set. Alright, now for interval notation, you're just again describing a set of numbers. And please, you always go from low numbers to high numbers, from left to right on the number line. And I'll make that little note below this, right? Always go, when you're writing an interval, always go from low numbers to higher numbers. I'll just say from low to high. Or in this case, again, left to right. I personally like having a graph up, a picture, and that makes interval notation much easier. So if you say, what are all real numbers greater than or equal to -2 written in interval notation? Well, if you go from low to high here, the first number I come across in the picture, right, this graph of this arrow, is -2. So I write down like this is the left end, right? You consider this the left end of the interval, the left end of the set of numbers. And then a comma. And then where is the right end of this picture? Well, there is no highest number. There is no right end. Right? There is no greatest number that's greater than or equal to -2. So to indicate that this goes to the right forever, put an infinity, right? Positive infinity symbol. Right? So this tells me I'm going from, the numbers I'm describing are from -2 and up, right? All the numbers greater than -2. And then you cap off the interval with either parentheses or a rectangular bracket. Now if you use a parentheses, right, a left parenthesis or a right parenthesis, this indicates that the number on the end is not included in the set. So number is not included in the set. But if you use a rectangular bracket, right, so like on the left end or on the right end, this symbol will indicate that the number on the end is included in the set. Number is included. Alright, so we saw earlier, look at the left end number in my interval. -2, is equal to negative 2. Negative 2 was included. I had a closed dot over negative 2. So to cap on negative 2 here, I'm going to put one of these rectangular brackets. Right, that indicates that negative 2 belongs to this set of numbers. Now infinity, right, infinity is not a number. It's an idea. Right? It's a concept. You're going to the right forever. All the numbers greater than negative 2 forever. Because infinity is not a number, it's technically not included in any set. So you're always, and I'll put that note over here, always cap infinity or negative infinity if you're talking about going to the left forever. But you always on the infinity symbol or negative infinity symbol, you're always putting the parentheses. Always, right? Because again, those are not numbers, so they can't be included in a set. And there you go. This is what they wanted from us eventually. Put this in a box here. They wanted to use interval notation. This is called interval notation to indicate this set of numbers. Right. Now I will do all 4 of these for every single one of these problems and circle the one that they want. Right. But there's a way to describe the set of number in words, in a picture, right, a graph, in this set builder notation, and in interval notation. All 4 of these things describe the same numbers. All right. Great. All right, so next example. So first we're given it in words. All real numbers between and including negative 3 and 5. So there's a description of the numbers in words, right? So that so including, so negative 3 is in the set, 5 is in this set, and everything in between, right? Negative 2, negative 1, 0, 1, 2, 3, 4, 4.5, negative square root of 2, whatever. Anything between negative 3 and 5 is also included. All right, so here's a graph. Right, here's a graph. So again, number line, and I'm not going to do this for every number line, but I'll put up some integers. Here's 0, negative 1, negative 2, negative 3, 1, 2, 3, 4, 5. And we're talking about, we want to indicate all the numbers between negative 3 and 5. That would be these numbers here. All like I said, negative 2 through 4, negative 2.5, 4.2, pi, right? Also all the numbers in between negative 3 and 5. And including negative 3 and 5. So negative 3 is included in the set. So I put a closed dot, a filled in point above negative 3. And 5. 5 is also included in the set. So I put a closed dot above that. Now, if I want set builder notation, again, say I call these numbers x again, right? All these numbers between and including, negative 3 and 5 represent possible values of x. So in set builder notation, I would say that this set of numbers is all the numbers x such that x is between negative 3 and 5. Now this would be a compound inequality. Negative 3 is less than x, and at the same time x is less than 5, right? This is what it means for x to be between negative 3 and 5. But again, you also have including negative 3, so equal to negative 3 as well, equal to 5 as well, right? So this is the compound inequality describing numbers being between negative 3 and 5, but also including them. Right, so negative 3 is less than or equal to x, and at the same time, x is less than or equal to 5. And close the set. This is called set builder notation. And then finally, the one they want, right, the interval. Again, look at my picture. Go low to high, left to right, and only describe the numbers I've indicated. Starting, I enter this picture of the numbers I've indicated at -3. And then I keep going until 5, and then I exit this picture. So the right end is at 5, not infinity. Right? Like the first example, it doesn't go to the right forever. All right, now that I've got an interval, the left end and right end pointed out, we're going to cap them with either parentheses or brackets. But because they are included, right, -3 is included in the set. So a rectangular bracket on this, not a parenthesis. Right? 5 is included in the set. So again, a rectangular bracket. And there we go. This picture here, this interval notation, describes, indicates all the numbers from -3 to 5, right? All the numbers between -3 and 5, including -3 and including +5. And once again, since that's the one they wanted, I'll put it in a box. I'll circle it, right? Great, but once again, 4 different ways to describe the same set, and I'm going to do this for all of these. All right, great. Example 3. So again, we're given in words first, all real numbers less than or equal to -1 or greater than or equal to 1. So the word or is very, again, I said this earlier, this is very inclusive. We're going to include all these numbers also, or all these numbers will also belong to this set. It's the word and that's much more restrictive. So there's, again, a picture's easy. 0, 1, -1, right? And I'll just, indicate the numbers described to me in words. All the real numbers less than or equal to -1. So less than -1, that's all, -2, -3, -4, and so on. All these numbers forever, right? Little arrow. Or equal, right? Or equal to -1. So -1 is also included in the set. So I put a closed dot, over -1. Or, also included in this picture, the numbers greater than or equal to +1. So all the numbers greater than +1 are to the right. Or equal, again, or equal. So to +1, 1 is included. And here is a picture of this set of numbers that's being described to us. Now in set builder notation, again, if I just call the numbers where being described x, or whatever variable you want, this is the set of all numbers x such that, x is less than or equal to -1, or, right, the word or is thrown right in there, this other set, if there's a gap, if there's a break in the picture, a gap between intervals, then the word or will be involved, I promise you. And then this other piece of the picture, x is greater than or equal to +1. And here's the set builder notation for this same set. But then finally, the interval notation. Now, as I mentioned, there's a gap. Right, there's a big gap here. A break in the graph, empty space between the two pieces of the picture. So, there are 2 intervals, right, that I need to be writing, right, because of this gap, right? If there's ever a gap or a break or a hole in the picture, you're going to have to write an interval for each piece of the picture. So this and again, always left to right, low to high. All right. So this first picture, this first piece of the picture, there is no left end. Right? I'm entering this piece of the picture at negative infinity. Right? So negative infinity to the left forever. Then going left to right, I exit the first piece of this picture, this first interval, at -1. Right? And as I mentioned, you always put parentheses on the infinities, positive infinity or negative infinity, right? That's not a number. And we said already, -1 is included in this set. So there's a rectangular bracket on -1. All right, so this interval I've written is for this left piece. All right, then there's a gap, a break in the graph. Now to represent that gap in set notation, we're using what's called the union symbol. All right, make a big U. All right, this is the union symbol. Right? And it really just represents the word or. Okay, the word or in my words here in this inequality in the set builder notation, the gap really kind of is represented by the word or. So this union symbol represents this word or in set notation. So this kind of represents the gap, the break, the hole. And then I have the second piece, the another interval, which starts at 1 and doesn't end, right? It goes to the right forever. So I do 1 comma and indicate that with a positive infinity. And as I've mentioned, you always cap the infinities with parentheses. They are they're not numbers. But 1, right? 1 is included in the set. So another rectangular bracket there on 1. So I have the interval notation for this first interval, a gap, represented by the union symbol, and then interval notation for the second interval, the second piece of the picture. And we're done. This is the interval notation for that set of numbers that's being described to us. All the real numbers, less than or equal to -1 or greater than or equal to 1. Wonderful. Okay. So something similar here for example 4. Alright, so here again in words, we have all real numbers less than -2. Notice it's just less than, not less than or equal to. So just less than -2. So -2 is not going to be included here. Or greater than or equal to 3. Right, so 3 will be included, right? You got the or equal to 3. All right, so there's a description in words. Here's a graph, right? A picture. And we're looking to indicate all the real numbers less than -2. That's these numbers here, right? To the left of -2, but not -2 itself. Just less than, just left of. So to indicate this, to indicate that -2 is not in this graph, not in this set, I'm putting, see this open point, a hole above -2? So that indicates that -2 is not in the set. Or, also in this set, greater than or equal to 3. So to the right of 3, right, all the numbers greater than 3 or equal to 3. So a closed point, right, a full dot over 3 to indicate that it's included. Now in set builder notation, once again, if I call these numbers x, this is the set of all x such that, x is less than -2 or x is greater than or equal to 3. And writing that compound inequality with the word or. And there's, set builder notation for this same set of numbers. And then finally, what they're asking us for is, the interval. Once again, See the gap. There is a break in the graph. 2 pieces to it, so I'm going to be writing 2 intervals and connecting them with this union symbol, right, to represent the gaps. So the first interval is going from negative infinity, right, from left to right, always, low to high, negative infinity up to negative 2, right, and that's where this piece stops. You always cap parentheses with negative infinity, and this time, negative 2, right, we said that's not in the set. So I'm capping negative 2 with parentheses. Negative 2 is not included. So there's the interval describing all the numbers less than negative 2. And then for the gap, right, the break in the graph, put the union symbol. And then this next interval goes from 3 to infinity, from left to right, 3 to infinity, 3 comma infinity. But 3 is included, right, 3 is in the set, so a rectangular bracket on that. And infinity always parentheses, right? Infinity is not a number. And there you go. Right, here's the interval notation for the set of numbers that's being described to us. Great. All right. Now in the next couple examples, we're not given a description in words. We're actually given a description in what's called, set builder notation. So this is all numbers x, and we're just talking about real numbers here. Such that x is, you saw this earlier, this is betweenness, right? X is between negative 1 and 3. And notice there's no equal signs, no half equal signs under these. So that means that negative 1 is not included in the set. 3 is not included. So in words, this would be all real numbers between but not including not including negative 1 and 3. Right, just describing the numbers in words. Do a picture, right, a graph. Right. All these numbers that are being described here that satisfy this inequality are, 0, 1, and 2, and all the numbers in between, right? Negative half, 2.5, right? Whatever you want, right? As long as it's between negative 1 and 3. But not including those two. So above negative 1, I'm putting this open point. And above 3, right, I'm putting this open point. So there's a graph of the same set of numbers. And then again, the thing they actually want from us, right, the interval. Well, now there's only one piece, right? There's no break and then a separate piece in the picture later. There's just one piece, so just one interval. Starts at negative 1, ends at 3 as I go from left to right, so negative 1 comma 3. And then neither of these endpoints, negative 1 or 3, are included. So parentheses on negative 1, parentheses on 3, and there you go. Right, there's the interval notation for this set of numbers between negative 1 and 3, but not including negative 1 nor 3. Great. All right, so here's, again, set builder notation. All values of x that are greater than or equal, right, or equal to 7, right? This is all real numbers. I'll describe it in words, right? All real numbers that are greater than or equal to 7. Right? Greater than or equal to 7, right? Describing it in words. Here's a picture, right? A graph. So here's 0, 7's over here. Now I'm not going to write out every integer now. 7's over here to the right of 0, and we're just indicating all the numbers, 8, 9, 10, all the 7.1, all the numbers greater than 7, and 7 itself, right? 7 is equal to 7. So I put a closed point over that. There's the graph. But then finally, right, the interval notation, the one they want from us. Again, there's only one piece here. There's no break and then another piece of the graph, just one interval. Starts at 7, goes to infinity. Right? So 7 comma infinity, going left to right, low to high. 7 is included, right? So bracket on 7. Infinity is not a number, right? So parentheses on infinity. And there you go. And these should get pretty easy after enough practice, right? You get the hang of this stuff. Okay, great. All right, so I got just a couple more here with, set builder notation. So here x, the numbers being described are all x such that x is less than 4, right? So this is all real numbers that are less than 4. But notice not equal to 4, right? Just less than. So all real numbers, less than 4. There's a description in words. We can make a graph. So here's 0, 4 would be to the right of 0. And the numbers that satisfy this are, 3, 2, 1, 3.9, -5, right? All the numbers less than 4, but not 4 itself, right? So an open point, a hole above 4. And then the interval notation for this, again, low to high, there is no lowest end, so it's negative infinity for the left end, and then it goes up to 4, and parentheses on both, right? Always parentheses on infinities, and you put in parentheses on the 4 because, again, it's not included in the set. And here's the interval notation for this set of numbers being described, right? All the numbers, real numbers less than 4, but not including 4. All right, then here, number 8, we're given all x such that x is all real numbers. X is any real number, all real numbers or any real number, right? Same thing. Yeah, so this is just all real numbers if you want to describe it. I mean, it's right there. Every real number is in this set. So there's a description in just purely words. If you were to graph this, right, this would be an interesting graph. Here's 0. Every number on the number line is included. So that's just indicate that going, left and right forever. Every single number, right, is included in this picture. All right, so the interval for this. Now again, there's no hole in this, there's no break, there's no gap, so I'm not going to be, using union symbols or anything. It's just one big interval. And the far left end is at negative infinity, comma, and then go to the right. The far right end is at positive infinity. And you always cap these with parentheses. So here's your interval notation for the set of all real numbers. Everything from the far left to the far right, from negative infinity to positive infinity, right? Everything on the number line, however you want to say that. Great. All right, so those we were given set builder notation and asked to, describe it in other ways in interval notation and stuff. The next few examples we're given a graph. So here we're given graphs and again asked to write the interval. Now the interval's easy, right? Here this is all the numbers between -2 and -1. Notice that -2 is not included, but -1 is, right? -1 is included, close point. So the interval, right, this picture here, the numbers are going from -2 to -1. -2 is not included, parentheses. -1 is included, bracket. And that's all they want, right? The interval notation. Now, if you want, you could say this is, all real numbers between -2 and -1, not including -2, but including -1, right? I don't know. that is kind of cluttered here, but not including -2, but including -1, something like that. And then the set builder notation, it'd be all, again, if I call the real numbers, values of x, be all values of x such that, x is between, remember the between inequality, compound inequality like this, -2 and -1, not including -2, but including -1. So I put the little half equals by the -1 there, right? X is less than or equal to -1, but only greater than -2, right? And there you go, right? There's, again, all 4 ways to describe the same set of numbers. All right, number 10, given another graph, notice there are 2 pieces. So there will be 2 intervals here with a union symbol, right? The union will represent the gap, the hole in the graph. So the left interval, right, going left to right, is from -infinity up to -1. Always parentheses on the infinities, and -1 has an open point above it, so it's not included. Right? So there's the interval notation for this set of numbers here, all the numbers less than -1, and then to represent where the gap is, the union symbol. And then this second interval goes from 2 to infinity as you go from left to right, right? 2 comma infinity. 2 is included, right? Bracket on that. And always parentheses on infinities, right? And this is what they're asking for, right? The interval notation. But if I were to describe it in words, right, it would be all real numbers, less than -1, or, right, or greater than or equal to 2. Right? There's a description of these numbers in words. And in set builder notation, once again, if I call the numbers I'm representing x, it'd be all x such that, x is less than -1, or x is greater than or equal to 2, just writing inequalities. But again, all 4 of these things describe the same set of numbers. All right, then my final graph here, all these numbers are, left of 4 and equal to 4 as well, right? 4 is included, you got a closed point. So that'd be from -infinity up to 4, parentheses on -infinity, and then, bracket on 4. Right? There's the interval notation for that set. But if I want to describe it in words, I'd say it's all real numbers, less than or equal to 4. And if I wanted to use set builder notation, it would be, again, if I use x, you could use whatever letter you want. Just make sure people know that you're indicating real numbers here. It's all real numbers x such that x is, less than or equal to 4. I put a little inequality there. Again, all 4 of these things describe the same set. All right, and then finally, in my last examples, we're not asked for interval notation. We're given interval notation and asked to write the interval in, that set builder notation. All right, but once again, I'm going to do all 4 of them. All right. So the first interval from, from -infinity to 6. Here's the graph of this. 0, here's 6. These are all the numbers less than 6. Right. Everything less than -infinity up to 6. But notice there's a parentheses on 6, so that means 6 is not included. Right? Parentheses on 6, so I'm putting an open point above 6. This is just all real numbers, if you're describing it in words, less than 6. And then finally that set builder notation, which is what they want. I could say it's all values of x such that, x is less than 6. And I'll put this in the box. This is what they wanted. Set builder notation. Right? Again, once you get the hang of this, do enough. And I would recommend doing all four of these for any set of numbers, any set of real numbers you're given. All right, get practice in writing interval notation, making a graph on a number line, writing set builder notation, describing the numbers in words, and seeing that they all work together. All right, example 13, interval, from 4 to infinity. So this is all the numbers greater than 4, but notice there's a parentheses on 4. So greater than 4, but not including 4. So again, here's a graph, easy to make a picture. There's 0, here's 4 to the right of 0. This is like 5, 6, 7, 8, 4.1, but not 4 itself. Right? All the numbers from 4 to infinity to the right forever, but not including 4. So an open point on 4. Once again, I'll describe it in words. We have all real numbers. Greater, strictly greater than 4, but not including 4, just greater than 4. Right? And there's the words, and then set builder notation, which is what they want. All values of x such that, x is greater than 4, right, but not equal to. And again, pretty simple after all these examples I've been going through. Should be pretty quick. Okay. All right, so here we have an interval. I'll draw a picture first. -3 is to the left of 0, 5 would be to the right. Notice there's a bracket on -3, so -3 is included in the set. I put a close point above that. Parentheses on 5, so 5 isn't included. And it's all the numbers in between. It's going from -3 up to 5, right? These numbers here, left to right. And there's your picture. Right? So this is all real numbers between -3 and 5, including -3, but not including 5. Including -3, but not 5. Right? No, that's right, but not 5. Okay. So there's a description in words, and then the set builder notation. All values of x, again, whatever letter you want to use, such that, and remember the betweenness, right? This compound inequality. Between -3 and 5, including -3, right? So that little half equals sign on the -3 part, but not including 5. So just x is strictly less than 5, right? So -3 is less than or equal to x, and x is less than 5. And there you go. All right. And this last one, we have two intervals. See with the union, there's a gap in this picture. 0, we got -4 and 1 are mentioned, right? There's -4, say there's 1, and then you got the number 9 mentioned as well, which would be to the right of 1. And look at this first interval. This is from -4 to 1. And then there's a bracket on both, right? So -4 is included, 1 is included, so I put closed dots above those. Then you have the union symbol, right, representing the word or, which will represent a gap in the graph. And then you have from 9 to infinity, another piece, right? So a little arrow, all the numbers greater than 9 and including 9. So a dot on 9. So this is all real numbers. All real numbers, between and including -4 and 1, or, right, for the gap, the union symbol, greater than or equal to 9. Sorry about the tininess of my writing here. I'm running out of space, but all real numbers, between and including -4 and 1, that's this interval, or for the union, and then greater than or equal to 9. Cool. And then finally, what they want, set builder notation, say it's x again for the numbers. All x such that, x is between and including -4 and 1, right? Or x is greater than or equal to 9, and then you put the word or in there. Got both these inequalities describing both these intervals, and that's it, right? So again, pretty simple stuff after a while. Hopefully you get the hang of it. And I would, like I said, I would recommend describing a set of numbers in all four ways. Interval notation, graph, words, set builder notation, just to get the hang of them. And also, make sure that they all kind of make sense together, that they all describe the same set of numbers in the same way. Right. Great. All right, so I'm hoping that watching me go through these 15 examples here help you in some way, when you're asked to use interval notation or describe a set of numbers using interval notation or set builder notation or a graph or words on your own. And thank you very much for watching.